Oi, speaker, can you play me Do You World?
I'll play Do You World Radio for you.
So this is Oi, speaker. And, well, it's listening to me again because that's the Wakeword that I've been training it. But I can ask it to do stuff like play me DJ Mazda on YouTube. So it can play music from the radio, it can play music from YouTube, it can detect a trained wake word that I've given it. This is currently running on PC and there's a little web interface for it. So you can talk in the chat, and this is what I was just asking it. You also have settings where you can specify hints and information to help it. Oi, speaker, stop. This is currently running on PC, but it's also running on a Raspberry Pi that I've got here, and I can use the PC to offload some work to it. Oi, speaker, play NTS. And that's actually being transcribed on the PC and then playing it on a Bluetooth speaker. Oi, speaker, stop. What I have here basically is, web interface, audio playback in a number of ways. I can set timers. Code-wise, we're looking about 1,300 lines of Python now. It's not that complicated, but there's a player, speaker context. We can set timers, so you can have timers and you can name them and it'll track those for you. I won't demonstrate that because it's not that interesting. There's some performance timers and utility functions in there. And then there's a bit of a flow for the conversational aspect of it. So I'll do a demo of that actually. If I start the speaker up, actually, it has a wake, like a startup sound as well. So that is the startup sound, a dub siren. And then I could go, oi, speaker. I'm just talking to you now. Can you just respond to me and give me a follow on so I can show the feature?
Sure, I'm listening. What would you like to talk about? I can help you play music, search for videos, set timers, or just have a chat.
So this one had a follow on with it, which means it gives you a chance to respond to the LLM without having to re-trigger the wake word. And then so we could ask it a question. Can you tell me the football fixtures that are going to be this weekend on the what's going to be the date? 22nd of May or 3rd of May. And it already has
I'll search for the football fixtures this weekend.
Preferences and stuff, so it could probably have a hint about what it should search for.
Let me check what's on for May 3rd. Let me search more specifically for Premier League fixtures for May 3rd, 2026. Great. For the weekend of May 3rd, 2026, here are the Premier League fixtures. On Saturday, May 2nd, there's Arsenal versus Fulham at 5:30, Brentford versus West.
Anyway, you get the idea. So I can talk to it, I can get it to play music, and I can get it to set timers and things like that. Other features that I can add, I want to add Home Assistant and those sort of things, but that'll come in time. The Python code in here, like I say, about 1,000 lines of Python. I've carefully sort of kept an eye on how this has been built up, kind of working myself and using Claude Code a bit to kind of offload some stuff to. But there is the web app, which I was just showing you earlier, with the chat, the settings. Oh, it's not running at the moment, but the logs and all of that stuff. And that has been completely vibe coded. So that's a bit of Python code, like only a few hundred lines. It has remote procedure calls, so it's using fast API, and it has RPC for transcribe and speak. That's how other speakers can send requests and you can process them. And then there's a static website, which is, let's see how much. I mean, it's not that much. It's only 400 lines of code, but that one I've not even really looked at it. I've only just said, move the button, make it bigger, change the font, whatever. I don't care about that. The speaker software itself in the Python, I wanted to make sure I kept it in good nick. So yeah, basically the hardest thing so far has been to train the Wakeword, and I think that was only because I made some mistakes. So at first I started trying to use a Google Colab notebook for training it, and I tried to use this, but it didn't work. So then I went on a bit of a tangent trying to set up my own training, or basically building it to get it to run. Okay, so we're on here, and I think that I'd like to go through how to set up Open Wakeword training. That it was suggested to do it on WSL because the Google Colab notebook doesn't work, and I thought it'd be quite funny to do it on record like this and do it by voice, because we're training a Wakeword for the speaker, which is also a chat LLM voice to text thing.
Ah, yeah, that's brilliant. It's properly meta in it. Training a Wakeword for an AI speaker by talking to an AI.
So then I went on a bit of a mad one, going through setting up Python, installing Python on WSL, installing different versions, being told dependencies that don't exist or incorrect things about the repository. I was just sort of scrambling, just trying to get something running. Slowly made, bits of progress, but then I decided to wonder, actually, hang on, why is Claude keep telling me these hallucinations? So if I'm on Claude here, actually, so it says it's on Sonnet, or I could choose Opus, but if I go into voice talk mode, hello Claude, can you tell me which version of which model you are?
Hey Alex, I'm Claude Haiku 4.5, the latest iteration of the Haiku model. It's designed to be quick and conversational, which suits voice chat quite well.
Okay, so there's the problem. Haiku is the less powerful, smaller model that's just for more quick chat. So that was why it was telling me incorrect information. So it sent me on a wild goose chase, installing WSL and other things. So there is this website, Open Wakeword Training, that you can sign into. I don't know if you pay for it or what you have to do. But it didn't tell me about this. But anyway, I didn't use this. In the end, I've got my own training infrastructure, which has worked. So inside the OiSpeaker repository, there's training, and then I have training data that I've gathered. This isn't in the repo, but it has some scripts which can generate this data for you. And I think it's quite interesting to go through the process manually, because I think that I've got some better insights into what it does. So the way that it works, in the training data, you have essentially just negative samples and positive samples. So positive samples are
WeSpeaker.
This is synthetically generated ones, or I've got a bunch of others that I can go to. So I've got ones, these are ones of me. Oi, speaker. Oi, speaker.
Oi, speaker.
So we got oi speakers, and I've got some more text to speech.
Oi speaker.
Just randomly generated ones. So you have a load of audio clips that say the word, and then so I'm talking, and I'm just going to talk. A load of them that a Wakeword capture. This one's a bit clicky, but they are false positive samples currently, which is quite easy. So this is the basic principle of it. Hey speaker. That one said, hey speaker, which isn't quite the Wakeword. And then inside the false training data set, there's
cease to advance. Why do we yet leave that cell? Cease to
a load of synthetically generated samples. So we have negative samples, positive samples. There's some scripts that downloaded those synthetic voices. They come from Libra TTS, which you can download. Then there's a bunch of false positives I record myself, and then there's a bunch of synthetic once, and then you run it through the training script, which is in here, and it essentially just does matrix multiplies. So I can run the training, point it at the positive and the negative samples. It applies from some augmentation onto the clips, background noise and stuff like that. If you want to, that caused me a problem, which I'll go into detail. Then it changes the lengths of the clips. The way that it actually works, the model, it detects the end of the thing, so the speaker part. It doesn't detect the whole word, because Open Wakeword only ingests about 1.5 second chunks of audio, or maybe like 1.2 seconds chunks of audio, so it might not catch the whole thing. It just needs to catch the intent of the thing. So all of the clips and the positives are essentially clipped to these windows and used as positive samples for the end of the OI speaker part, and then you can get the positive sample from the start of it as well. So that's how the training works. And then essentially what it's doing is pre-processing the audio a bit to make all of the clips an ingestible length and format. And then it runs these epochs of training that you can see where the loss function changes and the accuracy increases. It doesn't take very long at all, especially on this machine. It's only a 5060, but it's got CUDA, so training is reasonably quick. And it was reasonably easy to set this all up and extract the training from Open Wakeword, because there was some dependency issues that I just couldn't get around with running it myself. And at the end of it, what we get output is the OI speaker model, which is an ONNX file. So there's a website called Netrun, which is quite useful for visualizing these ONNX files, which are essentially the output of a neural network. And this is this is Open Wakeword network architecture. So we have some batch sizes. Essentially what this part does, shape and reshape, it's just making a flat list of the audio samples. Then they're connected matrix multiply. These are relaxed. What are they, like max or min, I think. It's just a few layers, a matrix multiplier, a max, so it makes sure it gets rid of negative numbers. The matrix multiply can find features within the audio clips, and then the sigmoid puts it into a 0 to 1 range. So it's quite basic. You know, there's only really 3 matrix multiply layers to it, but it can detect features in the audio from that, and that's all that it needs to do. So that all sounds easier said than done, because I actually got this all working, and then I was recording this because I thought this is going to be easy. I'll do a coding session. Oi speaker. Oh my god, it's worked. I just addressed you as Oi speaker. It worked. It actually works. We trained it. Oh no, the model it works, but it doesn't not work. So what I decided to do was add some functionality into the speaker. Here's just the code where it is. You can pass a flag to the speaker to say record negatives, and that means whenever the wake word is activated, it will record the buffer of audio that triggered it. So you could just leave that running and it won't do anything, it won't do any commands, it will just be recording those, and you can just try and trick it. You know, it's like you're playing with the model and you're just seeing if it triggers it. Right, okay, so now it's running and it's giving me like a rolling score. That triggered it. Oh no. And then you can also do record positives, which just records small snippets of you saying the wake word. And that was able to generate me lots of training data. Oi, speaker. Oi, speaker. But even still, after getting better training data, I was still seeing some problems. So I had to dig into it. There were some mistakes from this code where things had been cut up badly, or there was positives in the negatives by accident, just because of bugs in the code that I'd written from generating it. So sweeping through the data and making sure it was clean was important. But then still, I was finding it triggering very unnecessarily. So I started to dig a little deeper and added some diagnostics. So this was basically running the output. This runs the model with your training data and then shows you the scores that it gives. The way Wakeword works, it gives you a score between 0 and 1 based on probability of if the wake word has been triggered. And as you can see here, there's a lot of negatives that was scoring highly. So there's not very much a differentiation between positive and negative samples. So then I started digging into it a bit more, and what I realized is the code that I'd got LLM generated code to augment the samples to try and give me more training data by putting noise on top of the positive samples. It was actually putting some of the text to speech on top of the samples. So these were just basically garbled, overlapping audio of voice. So it was no wonder it couldn't really differentiate between the positive and negative samples. So I got rid of the augmentation. And later on I might fix it, but I've got some more realistic recordings now with reverb and stuff like that in there. And then I was able to retrain the model with it fixed and get this better distribution. After some further, so now you can see more of the negatives are at the 0 side, mainly positives at the 1 side, but there are some positives that are around at 0 as well. So then I analysed some of those clips. Some of them were genuine false positives, but some of them were a bit cut off or a bit strange. And so then I again conditioned my data and then managed to get to this, which is the current model. And you can see that it's very much like 0 or 1 almost, which is really quite good. This isn't complete yet. I think there's some more edge cases to handle, but I'm pretty happy with how this was. If it wasn't for that mistake in the first place, it probably would have come together a bit more quickly, but I think it was interesting to have to debug and figure out the problem. That's it really. So the wake model's working, the training's working, and I have the training that I can use it again to continually fine-tune the wake word. I've got the audio playback, I've got web interface. So the next thing is to make the speaker itself and start looking at the hardware. So software stack I think's pretty much done. There will be some new additions and new skills and tools that can be added, but overall I'm pretty happy with how this has gone. So if you liked it, give me a subscribe and check out how the progress goes, or give me a shout if you're interested or if you have any advice, but until next time, bye.